Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining the process of Unix kernel support for signals. That means when a signal is generated, how a Unix kernel will react. So that process I am going to explain in this video. And also along with that I am explaining a API, signal API, right, to generate a signal or to handle the signal. You need some prototype, right? I'm going to discuss that prototype, that is signal API, in this video. If you are not subscribed to my channel, please subscribe to my channel. To get the notification of my new videos, please click the bell icon. And please don't forget to like the video, and please don't forget to share the video with your friends. So let me begin the explanation. So in Unix system V3, that is V3 means that is one of the commercial versions of Unix system. So in early 1980s, V3 was one of the commercial versions of Unix system. Now we have Fedora, Ubuntu, like that. V3 was the earlier commercial version. In Unix system V3, each entry in the kernel process table slot as an array of signal flags. That means kernel maintains the process table, right? Every process will have the table. Process table contains process ID, and also all the other details related to the process will be there. In the process tables, we have a separate array for signal flags, one for each defined in the system. So what I am trying to say is, for every process table, in the process table, the array of signal flags is also maintained. That means all the signal flags will be maintained in the process table. So whenever the particular signal is generated, the process can the process can activate that signal flag, and it can take a particular action, right? It will maintain an array of signal flags. I discussed different types of POSIX supported signals in the previous video. If you want to know more about the POSIX defined signal, you can refer my Unix system programming playlist, right? So you know that every process maintains the array of signal flags, right? When a signal is generated for a process, the kernel will set the corresponding signal flag in the process table slot of the recipient process. For example, if a SIG alarm signal is generated, so that particular slot of that SIG alarm will be activated. The particular flag for that particular SIG alarm signal will be activated. Understanding, guys? For every signal there will be a flag. What type of for example, 20 flags will be there for 20 different types of signals. If any one of the signal is activated, based on what type of signal is activated, you are going to set the corresponding signal flag. For example, I told you SIG alarm, SIG SCGV, different types of signal flags will be there. So any signal can be activated. If any signal can be activated, based on that what type of signal is generated, a process can set the corresponding signal flag, right? I'll explain with a diagram, no worries. See here, if the recipient process is asleep, if it is sleeping, if the recipient process is sleeping, waiting a child to terminate or executing a pass API, the kernel will awaken the process by scheduling it. So if the process, the recipient process which is going to take that signal, if it is in the asleep, the kernel should activate that process, because that process should take the action, right? That's why. When the recipient process runs the kernel, right, when the recipient process runs, the kernel will check the process user area that contains array of signal and playing specifications, where each entry of the array corresponds to a signal defined in the system. Whenever the recipient process runs, it's the kernel task to check the process area that contains array of signal handling specifications, because then only it can identify which entry of the array corresponds to a signal, right? That's right. The kernel will consult the array to find out how the process will react to the pending signal, because the process has to take the decision. It can do three things. Either it can take the default action of the signal, or it can ignore the signal, or it can call the user defined handler function, right? You know that. If you want to know more about that, you can refer the signal video, introduction to signal video, in the Unix system programming playlist, right? Getting, guys? So it is very simple. Every process maintains the array of signal flags. Depending upon what type of signal is going to be generated, that particular flag is going to be activated in the process table slot, right? If the recipient process is sleeping, if it is asleep, kernel will awaken the process by scheduling it, right? So you can see here. So this is the simple diagram here. So here the kernel is going to maintain a process table. In a process table, along with the process details, I am going to maintain the array of the signal. You can see here, here what is the signal that is present in the array here? Sig alarm. So in the same way, you can see so many different signals, flags can also be there in the array of signals. Kernel is going to call the particular, kernel is going to set the particular flag of the signal. For example, here assume that sig alarm, right? Sig alarm, that is alarm is generated, that kernel will set the flag of the alarm. In the same way, if sig kill is activated, then the particular flag of the kill signal should be set like that. Hope you are understanding now, right? So kernel is going to maintain a process table. In that process table, we have a separate slot for the array of signals. All the signals flags will be maintained in that array. So based on what type of signal is going to be generated for the recipient process, that particular signal flag will be activated. Here in this example, I showed sig alarm, right? In the same way, so many other types of signals can also be there in the array. Hope you are understanding, guys. Next, if the array entry contains a 0 value, the process will accept the default action of the signal and the kernel will discard it. So here in the array entry, for each flag, obviously if it is a 1 means it will be activated. If it is 0 means what? The process will accept the default action of the signal. If the array contains a 0 value, the process will accept the default action of the signal and the kernel will discard it. Just kernel will take a default action. If the array entry contains a 1 value, I told you, the process will ignore the signal. 0 means it will take the default action. If the array entry contains 1 means it will ignore it. Sig alarm, don't get confused here. If a value of this, any of this flag is 1, it will ignore it. If any of the value is 0, if value is 0 for any of this sig alarm, it will take the default action. Not sig alarm, any signal for that matter. If the value is 1, it will just ignore that signal. If the value is 0, if the flag value is 0, it will take the default action. For every signal there will be a default action. You know that, right? Next, finally, if the array entry contains any other value other than 0 or 1, if the array entry contains any different value, it is used as the function pointer for a user defined signal handler routine. That means other value, if other value is there in the entry, you can use it for the user defined function pointer. If you can use to define your own right handler routine. The kernel will set up the process to execute the function immediately and the process will return to its current point of execution if the signal handler does not terminate the process. So the kernel, what it will do once it gets the signal handler routine, it will set up the process to execute the function immediately. Immediately it will tell the process to execute that user defined user defined signal. So once the function is executed, the process will return to its current point of execution, right? If the signal handler does not terminate the process, if terminate the process, no worries. If it does not terminate the process, it should return to its previous point or current point of execution. And if there are different signals pending on process, just remember, one process can receive different signals. It's not a rule that process should receive only one signal. No, user can do multiple tasks simultaneously. That's why multiple signals can be sent to the process. If there are different signals pending on a process, the order in which they are sent to recipient process is undefined. Any signal can be sent in any order. Here we don't have any we don't maintain any ordering here, right? If there are different signals pending on a process, the order in which they are sent to a recipient process is undefined. Obviously, order we don't maintain here. Any signal can come first, any signal can come last. And one more important thing, if multiple instances of signals are pending on a process, so that means so many different signals are pending on a process, it is implementation dependent on whether a single instance or multiple instances of the signal will be delivered to the process. It depends on what type of standard you are using. If you want, you can take the single instance, or if you want, you can take the multiple instances and you can you can deliver it. But it's purely dependent on what type of standard and you are using, right? And in Unix system v3, each signal flag in a process table slot records only whether a signal is pending, but not how many of them are present. Just remember that a signal flag, whatever the signal flag you are going to maintain a process table, especially in system v3, it records the signal flag in the process table in the system v3 records only the pending signals. Only the information about the pending signals will be maintained in the Unix system v3 in this process table slot, right? So this is the process, right? Now I'm going to explain the signal API. So the signal API, all Unix system and ANSYS support the signal API. Why I am going to use the signal API? Signal API, which can be used to define the signal handling method. So you can use a signal API to define the signal handling method. Here the prototype, you can see here void signal. So you have a argument int signal number, void handler int. Now I will explain this argument. See here, signal number is the signal identifier like sigint or sigterm defined in signal.h. Signal number is the signal identifier. I told you, for every signal there should be identifier. You need to identify that particular signal. How we are going to identify that signal? By using the signal number. So that is the first argument here. You are creating the signal. When you are creating the signal, right? When you are creating the handler is like address, right? So how we are going to do that means using a signal number. And what is the handler? Handler is the function pointer of a user defined signal handler function. This function should take an integer formal argument and does not return any value. For example, see below, attempts to catch the signal term, ignores the signal int and accepts the default action of the CGV signal. See here, I will explain that. It's very simple. So handler means what here? Handler is the function pointer of a user defined signal. You defined a signal, you created a signal, right? And that signal handler is a pointer. The handler is going to point to that particular signal that you are created, right? And this function should take an integer formal argument. So a signal number is an integer, right? It will take that signal number as an argument and it does not return any value. Just remember, when you are creating a signal number is the signal identifier, handler is the pointer to that user defined signal handler function. So here I am going to explain the example here. So this example attempts to catch the signal term, ignores the signal int and accept the default action of the SIG SCGV signal. If you want to know more about SIG term, SIGINT, you can refer the video Introduction to Signals in the playlist, right? In the playlist Unix System Programming. So it is very simple. This program, what it will do, first it will attempt to catch the signal SIG term. It will attempt to catch the signal, but it ignores the SIGINT, but it will accept the default action of the SIG SCGV signal. Three types of different signals we are going to see in this program: SIG term, SIGINT, SIG SCGV. And one more important thing, the pass API suspends the calling process until it is interrupted by a signal, and the corresponding signal handler does a return. Here pass API, what it will do, it will suspend the calling process until it is interrupted by a signal, right? We will see that now. So you can see there, catch, it is going to catch the signal. It's trying to catch the signal, right? Which signal it is trying to catch? It's trying to catch a signal SIG term. You can see in a main SIG term. What is that? Catch signal. It's trying to catch a signal, catch a SIG term, but what it will do? It will ignore. See here, in a catch signal, what is the argument I am giving? Signal number. I told you, right? Signal number. Signal number is identifier for that particular signal. For every signal there will be identifier. Signal number, catch signal. So to catch the signal, what I need? I need a, right? I need a number. I need a number. See out, catch signal. If it's tried to, if it succeeded in catching the signal, it will print that signal whichever is catched. Getting, guys? Signal SIG term. So catch signal is the function I'm calling here, but catch signal it's already defined. You can see that. So catch signal is the function, it's already defined. So I'm calling that function to catch the signal term, right? And next is signal int, right? What I will do for that signal int, right? Ignores the signal int. I'm going to ignore the signal int. That's why IGN means what? I'm going to ignore the signal int. Next, what I'm doing, third signal, SIG SCGV, that is segmentation. I'm going to take a default action. That's why DFL. I hope you're understanding, guys. Three different signals, three different types of actions. I'm doing it, right? So first I'm going to try to catch the signal term. So how to catch that signal means the function is defined here. What is the function name here? Catch signal. You can see there. What is the argument? Signal number. That is the identifier. If you want to catch the signal, you need the number, identifier. That's why. Second signal, what it will do? It will ignore the signal. What is that signal? SIGINT. It will ignore that signal. Next, third signal, what it will do? It will take a default action, which is the signal that is SIG SCGV. That is a segmentation, memory related signal. That is, if any error happens related to memory, SIG SCGV will be generated. So for that signal, what is the action it is going to take? Default action it is going to take. It is going to terminate. That is the default action. Pass API. You know that pass API suspends the calling process until it is interrupted by a signal, right? Pass API, it will wait for the signal interruption. It will suspend the calling process until the interruption occurs. Once the interruption occurs, right? Once the interruption occurs, it can, right? What it can do, it can continue with the calling process. Hope you're understanding, guys. Very simple. Here it is a very simple program. Three different signals: SIG term, SIGINT, SIG SCGV. First one, I'm trying to catch the signal. How I'm going to catch the signal means I defined a function here, catch signal function. I'm giving the argument signal number there. Based on the signal number, it is going to catch the signal. It will try to catch the signal. If it succeeded in catching the signal, it is going to print that. Cout is for printing. It is going to print the catched signal details and also the signal number. Here I'm going to catch the signal. I'm going to try the catch the signal SIG term. right? It's making an attempt to catch the signal sig term. In the second case, it is ignoring the signal sig int. That's why sigign. It's just ignoring that signal. In the third case, it is going to take the default action. That's why sig underscore dfl for a fig SEGV signal. It's going to take a default action. So what is the default action? It will terminate the process. So that default action will takes place because I am defining it as sig dfl. So pass API. So it will wait for it will suspend the calling process until the interruption occurs. Signal interruption should happen, right? For when a signal is generated, whatever the signal, these three signals, when an interruption should have occur, right? That's why it will wait for the signal interruption. It can be signal interruption can occur from any of these signals. That's why I am using pass API. Once the signal interruption occurs, I can continue with the calling process, right? You can see here sig IGN and sig DFL are constant. Sig DFL and sig IGN. DFL means default, IGN means ignore. That's why 0 means what? Default. 1 means what? Ignore. Right? The return value of the signal API is the previous signal handler of the signal. Whatever the return value. So whatever the return value of this handler, that is the value, previous value of the signal handler. Right? Right? One more important thing, Unix system v3 and v4 support the 6-set API, which has the same prototype. Instead of see here, what is the API I am using here? I am using a prototype. What is the API I am using here? Signal API. Instead of signal API, I can use a 6-set API also. Both the functionalities of both the signal is both the APIs is same. What are those APIs? 6-set and signal. I can use 6-set also, I can use signal also. Both the APIs are same. Whatever the actions it's going to take, everything is same. I can use 6-set also, or I can use signal also. Especially 6-set is supported in version v3 and v4. Right? You can see here signal.h. Obviously, instead of signal, what is the API I am using here? 6-set. You can see syntax is same for signal also, syntax is same for signal set also. Getting, guys? The signal set arguments and return value is same as of the signal. I already told, whatever the arguments, whatever the return value, each and everything will remain the same for signal and signal set. Both the functions set signal handling methods for any named signal, but signal API is unreliable and signal set is reliable. Why? You can ask a question, why signal API is unreliable and signal set is reliable means, because when a signal is said to be caught by a signal handler through signal set, when multiple instances of the signal arrive, one of them is handled with other instances are blocked. That means here it's going to take care of only if multiple instances are also there, it is going to take care, right? One of them, it will take only one first, then others are blocked. One by one it will take care. Even if multiple instances of signals are there, signal set, what it will do, it will take one by one. It will take one first, it will block others. Next second one it will take and will it block others. One by one it will take. Right? And it's going to handle it. And along with that, further the signal handler is not reset to sig DFT when it's invoked. That's why 6-set is reliable than signal. Why it is reliable means it can handle multiple instances without any problem. Right? That's it, guys. Hope you are understanding the concept. Suppose if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.